Okay, looking at equations with rational exponents. First of all, rational exponents are basically exponents that are fractions. So our first example, x to the 2/3 equals 16. Our goal, like in all equations, is to get x by itself, that is to solve for x. So we want to figure out what power or exponent to raise both sides to such that we're going to get just x to the 1. So if we take x to the 2/3, and if we think about what's going to make that 2/3 1, well, it's going to be the reciprocal, because if we multiply that, then we get x to the 2 times 3 over 3 times 2, which is 6 over 6, which is just x to the 1. That means we're going to raise both sides of this equation to the power 3 over 2. All right, so if we take our original x to the 2/3, and we're going to raise that to the power 3/2, and we got to do the same thing to the other side. So we have 16, and we're going to put a power of 3/2 on there. Okay, so on the left side, that's just going to leave us with x as we have seen, and on the right side, 16 to the 3/2 is like, we could think of that as 16 to the half cubed. All right, now remember that whenever we have anything to that 1/2 power, that is like taking the square root. So this is like taking the square root of 16 and then cubing it. So we know that the square root of 16 is 4. And so 4 cubed is 64. So our solution, x is equal to 64. Another example with rational expressions, or rational exponents, that is this one we've got here. Now we're going to want to rewrite this so that we can make it into a quadratic with using u substitution. So we did one of these before, so this is going to be our goal, to do u substitution. So I'm just going to do a little rewriting. If we take and write that x to the 2/3 as x to the 1/3, okay, that quantity squared, and then rewrite the 9, and then that's a times x to the 1/3, and then we've got the plus 14, and then equals 0. Here's where the u substitution comes in. If we let u equal x to the 1/3, and then replace x to the 1/3 with u in the equation, we end up with u squared plus 9u plus 14. So for now, it's eliminating having to have those rational exponents, or that rational exponent of 1/3 and 2/3. We have a quadratic that we can solve. This is going to factor for us. We're going to have u plus 7, u plus 2. That gives us the solutions of u equals -7 and u equals -2. Here's where we substitute back in what u is equal to, and we get x to the 1/3 equals -7, and x to the 1/3 equals -2. Now we do like we did in that first example, where we're going to raise both sides to a power. So we're going to take that x to the 1/3. We want to get rid of that exponent. So if we raise that to the power of 3, all right, and that is going to make that x to the 1. And so we do that also to the -7. All right, we raise that to a power of 3. So x to the 1/3 times 3 is like x to the 3 over 3, so that's just going to be x. And then if we cube -7, right? We're going to get a negative 343. All right, let's look at the other one. So again, we want to take that x to the 1/3. We got to raise it to a power of 3. If we do it to that side, we're going to do it to the other side. Raise it to a power of 3. It very nicely gets rid of that rational exponent for us. So we get x equals negative 2 cubed, which is a negative 8. Okay, let's look at another example. So again, if we rewrite this x to the 2/3 as x to the 1/3, and then that is squared, and then we've got minus x to the 1/3, and then minus 6 equals 0. We want to make the replacement. We want to say that u is equal to x to the 1/3. Now we go through, replace this x to the 1/3 with u, so that becomes u squared. And then we have a minus x to the 1/3, so that's minus u, and then minus 6 equals 0. Okay, we can factor that. So we're going to have u, and the two numbers that are going to multiply to a negative 6 and add to a negative 1 is a negative 3 and a plus 2. So we get solutions for u of 3 and negative 2. All right, but now here we got to remember we're going to make that replacement back. Replace that u with what it's equal to. X to the 1/3 equals 3, and x to the 1/3 equals negative 2. Okay, we want to get rid of that exponent of 1/3, so we think about what power we can raise that to. All right, well, it's going to be a 3. 3 times 1/3 is just 1. So if we do that to one side, we got to do it to the other. We end up with x equal 3 cubed, which is 27. And for x to the 1/3 equals negative 2, again, raise both sides to a power of 3. We get x equals negative 2 cubed, which is a negative 8. Okay, here's one more example with negative exponents. So first thing we want to do is we're going to rewrite with positive exponents. So that makes that first term 1 over x squared. All right, we take the reciprocal of the x, make the exponent positive. The second term, the 3 stays in the numerator because that doesn't have a negative exponent, but that x goes to the denominator, and then plus 2 equals 0. Okay, now we want to clear those denominators. So we multiply both sides by the least common denominator, which is x squared, both sides. Okay, so if we multiply by x squared times 1 over x, that's just going to leave a 1. X squared times 3 over x, that leaves a plus 3x, just one of those x's cancel. And then x squared times 2, we get plus 2x squared equals 0. 0 times x squared is just 0. So we've got a quadratic. Surprise, surprise. 2x squared plus 3x plus 1 equals 0. So we're going to factor that. Oops, I left off the 1. There we go. And because we have that leading coefficient of 2, that means one of our factors is going to have a 2x and the other one is going to have an x. So we want to multiply to a positive 1 and add to a positive 3. So really our only choice is a 1 and a 1 there. And it has to be positive. So setting those equal to 0, we're going to get x is equal to a negative 1/2. And x is equal to negative 1.